This woodcut shows the devastating earthquake in Basel in the year 1356. It was made around 200 years later. You can literally see the heaving underground layers. Church towers broke off and buildings collapsed. People were fleeing and trees fell over. Such historical earthquakes are fundamental for assessing seismic hazards. Knowledge of many such events allows us to estimate their frequency. Hello and welcome. Historical documents contribute to our understanding of earthquake activity. In this video, I will be showing you how. You will learn about the most important observational parameters of past earthquakes. Specifically, you will see how the historical magnitude and the depth of the quake can be estimated. But when is an earthquake considered historical? Today, earthquakes are recorded globally by seismometer networks. These observations make it possible to determine the location, time, and the exact magnitude of earthquakes worldwide. This is not possible for earthquakes from the past. They are called historical. For these, we refer to written sources. Identifying historical quakes is important for estimating seismic hazards. Extremely strong quakes occur relatively seldom. They have a large period of recurrence. In order to calculate it, we require information on as many seismic events as possible, including historical ones. For example, how frequent is an earthquake like the one in Basel? The further we travel back into the past, the more difficult it becomes to determine the characteristics of the quake. One other example is the earthquake from the year 1735 near Gießen to the north of Frankfurt. It is a good example for demonstrating seismic assessment. It is not as far back in the past as the one from Basel, and the historical sources are mostly written in German and not Latin. Also, newspapers already existed back then, which simplifies the research significantly. Shown here are earthquakes to the date to the north of Frankfurt. The data comes from the earthquake catalogue of Hesse. Large circles indicate strong quakes and small circles weak ones. The 1735 earthquake is shown here. It is registered in numerous lists of earthquakes, for example in the Chronicles of the Strangest Earthquakes from the year 1756. Many of these lists refer to others, whereby historians and seismologists are naturally interested in the very first original source. I will now show you this original source. It is a clipping from the Europäische Zeitung Frankfurt newspaper. It reads, Gießen, 22nd August. This morning, between 1/2 and 3/4 from 3 o'clock, despite clear skies and entirely windless air, such a shock was felt here that not only the furniture and buildings themselves, but also the court bell at the local town hall was shaken, such that it struck 6 to 8 times. The sentries on the wall also felt such tremors, and the birds were driven out of the bushes at the town moat, such that they flitted hither and thither. Based on this source, the location and strength of the earthquake were determined. Here, the strength of the quake is initially described with the macroseismic intensity. It estimates the effects on humans, things, and buildings. An intensity of 3 means that the shocks could be felt by a few people. A value of 4 means that many people will feel it. At an intensity of 5, small objects are already falling over in houses or are displaced. At a value of 6, damages in the form of cracks in the plaster and in walls may occur. The epicenter is typically the location with the strongest shocks and the resulting effects. In our case, the city of Gießen with a maximum intensity of 5. In new studies, additional documents on the earthquake of 1735 were evaluated. For example, a chronicle from the town of Hadamar. It says that such an earthquake was felt as to cause beds and children's cradles to move and chimneys collapsed. The town of Hadamar is located 45 kilometers west-southwest of Gießen, and collapsing chimneys are a characteristic of an intensity of 6. So, was the epicenter not in Gießen? Another source also suggests this. The small town of Freilingen, 20 kilometers from Hadamar in the Westerwald mountains, had maintained a postal station on the mountain road between Cologne and Frankfurt since the 17th century. Hence, reports from there quickly reached these two big cities. The British Daily Gazetteer writes, Cologne, August 23. Yesterday at 2 o'clock in the morning, a slight earthquake was perceived here and at Bonn, which did no damage. But it was more violent in the Westerwald insomuch that the inhabitants of Freilingen and several other neighboring places fled into the open country for fear of being buried under the ruins of their houses. Note that the inhabitants left their homes. This is another indicator for a macroseismic intensity of 6. Hence, data from these two new sources allowed the position of the historical earthquakes of 1735 to be determined now as being in the southern Westerwald mountains. The largest intensity, the maximum intensity, marks the epicenter. The magnitude, on the other hand, describes the strength of an earthquake source underground, in the hypocenter. The magnitude is also the physical quantity that is reported in the media today. Its estimation is important in order to be able to categorize historical quakes. The stronger an earthquake source is, the greater its effects on the Earth's surface. That is the intensity. How can we estimate the magnitude of a historical earthquake? This map shows observed intensities of the quake of 1735 color-coded. The maximum values in Hadamar and Freilingen, shown in red, have an intensity of 6. The oval marks the area in which the event could be felt. The mean radius of this area is called the radius of perceptibility, which in this case is around 80 kilometers. In conjunction with the maximum intensity, it allows the magnitude and depth of the earthquake to be estimated. The deeper an earthquake occurs, the lower its maximum intensity, at the same magnitude. Conversely, the radius of perceptibility increases the deeper an earthquake occurs, assuming the maximum intensity remains the same. This fact allows the magnitude m and the hypocentral depth h to be estimated via the maximum intensity I0 and radius of perceptibility Rp, according to the following formulas. M equals 0.437 plus 0.380 times I0 plus 0.789 times the logarithm of Rp. And for the hypocentral depth, logarithm of h equals m plus 0.154 minus 0.636 times I0 divided by 0.555. This allows the magnitude of the Westerwald quake to be estimated at 4.2 and the hypocenter at a depth of around 10 kilometers. It also places the epicenter at a point much further west than previously assumed. Using a similar procedure, it was also possible to evaluate the 1356 Basel earthquake. The results show that it had a magnitude of 6.9 and occurred at a depth of around 12 kilometers. Such destructive quakes only occur in the Upper Rhine-Graben once every 2,000 to 6,000 years on average. In this video, I showed you how important original sources are for assessing historical earthquakes. You have learned about the parameters of the maximum intensity and the radius of perceptibility and how you can use them to estimate the magnitude and depth of a quake. Various pieces of historical evidence on earthquakes are fundamental for seismic hazard assessment. They provide us with insight into events from the past and allow us to calculate the period of recurrence of large earthquakes.